My name is Bloem. I'm representing Dynasty. The Dynasty is a network working on dynamic analysis, simulation, testing, and mainly on the energy performance assessment of buildings. We are a part of a huge network, which is INIVE, and that is working on information on ventilation and energy performance. We took the initiative half a year ago, 6 months ago, to organize a symposium on the building as the cornerstone of our future energy infrastructure. And what I would like to present in my presentation today is a little bit the topics that we had asked several speakers to present, more or less the status quo of what is needed and what can be expected in the future if we consider that really the building is a part of our future energy infrastructure. And as you can see, we have been addressing all kinds of aspects, from directives, European directives and standards, ISO and standards related to it. We have been looking to renovation and the financing of renovation, monitoring and measurements in general, what is required at the level of research and testing, modeling and calculation, of course, and the integration of renewable energies. And also, there were 2 IEA EBC projects invited to participate. Let's start a little bit with the directives. What in Europe is going on, we are almost in 2020, so you see the renewable energy targets. They have updated the targets for 2030, and you have seen already also in the days before that renewable energy share is expected to be 32%, reduction of emissions 40%, and an improvement in energy efficiency 32.5. I don't know where this 0.5 is coming from, but they expect to be so accurate that they can give it in 1 decimal accuracy. And of course, also in the roadmap for 2030, there is the security of supply. So all the member states are asked to work on the infrastructure for, in particular, electricity and gas. And of course, there is also further look into the future, the roadmap for 2050, and that is giving aspects like climate neutrality, and where some member states have already announced that they would be completely carbon-free, but in fact, the roadmap indicates 80, 90, 95% reduction of the emissions. As a conclusion here, the main 3 pillars of this policy, of this energy policy of the European Commission is energy efficiency first. We would like to be the global leader in renewable energies, and, which is now addressed, that it should be fair to the consumers, and that's us, citizens. And in the past, they have not always been considered, but now they've put that really as one of the 3 pillars. Let's have a look at the renewable energy targets for 2020, and the one that is expected to be in 2030, that is on the far on the far left, 32%. And as you can also conclude from this graph, there is a huge variety from contributions to this renewable energy target. Sweden, in general, Scandinavian countries, they are leading in their targets, and they are often already ahead, and there are also countries that are really lagging behind. I'm from the Netherlands, and I must say that the Netherlands is far behind, but that has also a reason, because one of the things that is happening is that we get a lot of free renewable electricity from Germany and Denmark. They produce so much that they say, please buy it for almost nothing from us. So that is one of the reasons that in the Netherlands it's not developing with the pace that we have set already 10 years ago. But there are several reasons for this. What you miss here is the member states' targets for 2030. Only the European Commission has made one. So what it will be, and I was checking last week, there is not yet a new target by all the member states individually. European policy, already 20 years ago, they started to look to buildings. At that time, buildings were already the focus of where energy efficiency, energy savings should take place. So at that time, they have started to work on directives that should be applied and implemented by the member states. And so at the moment it is a series of directives, and I have only put here a few that are directly related with buildings and the scaling up from buildings to cities to whole member states. And you see there prominently Energy Performance of Buildings Directive. The first one was from 2002. You see also the Energy Efficiency Directive. It's a directive that is not considering the individual building. That is what the EPBD, the Energy Performance of Buildings Directive, does. The EED is addressing already more general, more global energy use and the efficiency of apparatus, of systems, appliances, etc. And in between you see the Covenant of Mayors, and that is making a link possible to urban areas or cities, but that is on a free basis. It's a voluntary basis scheme. But it was such a success when it was introduced about 10 years ago. It was such a success that there are thousands of municipalities in Europe, and not only Europe now, but also abroad, that follow this hints, this support, this information system, how to reduce energy and how to reduce emissions at the level of cities. If we have a look to the EPBD, the whole idea of the EPBD initially was to focus on individual buildings. But since we have 203 million dwellings, it became also a problem, because it's quite expensive to have every dwelling assessed for its performance. So about 10 years ago, they started to think about a methodology that should be less expensive and give the information that really was needed. So apart from the calculated or measured methodology to assess the performance of buildings, there has become now a third one, and that is the holistic approach, and that is based on administrative data. And for that purpose, it's very useful to have an INSPIRE directive, which is also a very successful European directive on location data. And it's so successful that it's also going all over the world now. It's implemented not only in Europe. By the way, technical implementation has to be finalized next year, 2020, by all the European member states of INSPIRE. So this holistic approach, I will come back a little bit later in my presentation. As said, they recognized already that EPBD should be less expensive, should not be only based on calculation or measurements, and that is why they have made a supplement in 2012, where they said, okay, we can have reference buildings. So you can compare a group of buildings with some reference buildings that are measured more in detail. And for that purpose, they have given minimum requirements for information, as you can see here. And there is also a link already to location data where I was talking about from the INSPIRE directive. There are nice publications of it, which are mentioned there on the top. And that is also giving a relation to energy for the building energy needs, but the energy systems as well, and the source or the carrier of energy that a building requires. And then one of the last slides on the EPBD. Last year, in 2018, the energy performance of buildings has been revised. The most recent one from 2010 is used for that, but there are some new features in it that is modernizing it and that makes it able to have new technologies in it. For example, it is looking to electromobility. Electromobility, so it gives already a possibility that the batteries of a car, for example, can be used in the building environment. So this directive has set what are the requirements for doing these kind of calculations. They have also introduced a smartness indicator, so that you may think, as you have heard yesterday and also today, this flexibility indicator, but they have called it smartness indicator. It's probably trying to do the same, but it's a way of dealing with the building that it is producing the energy and how to interact with the networks. And then another thing, I come back to that also, it is that they have made it possible that member states can have their specific requirements for the reporting of the energy performance and the assessment of the energy performance of the buildings by national parameters. New buildings, from 2021, all new buildings should be nearly zero energy buildings. But remember that at the moment in Europe, new constructions are less than 1% per year. Renovation, I come back to renovation. We have about 50% of the whole building stock in Europe that needs to have renovation. So, to give you a little bit the scale, 1%, less than 1% new buildings, and about 50% of buildings that are required to undergo renovation. Oh, here we are. So, connected to these directives are standards. And the standards, one of the reasons that they have had to update these standards is that it's not anymore only in Europe that they can be used, but they connected the SEN standards also to ISO. And the reason that they had then a whole new numbering system, it's given here as well. So it's now, for buildings, it's the 52,000 series of standards. And I've given, they are in place from since last year, and they are modernized, they are more dynamic, and they give a way how to calculate, for example, more the interaction with renewable energy. That is one of the reasons that also there is now the choice between hourly calculation and monthly calculation. So that is new, and the other thing that is new is really that the national choices can be introduced in the annex. So apart from national standards, this is then the minimum requirements for the national standards. The energy in the building sector, if we look from different perspectives, then we can recognize that's really the politicians, let's say the government. We can recognize their industry, we can recognize the citizen, the end user, and probably they are linked all by the banks, by how to finance everything that is going on there. I've made this design to explain also to my students how it's work, how it works in reality. If we look a little bit to the characteristics of these circles, yeah, if we go to governments, then you can recognize that they are not that long in place. They might change targets, they might change subsidy programs, all these kind of things. That is typically for the governments. But they are defining the law. They are discussing at a completely different level than you and me are discussing what would be the future look. Then we have industry. Industry, they, by definition, they need to make money. So there is a commercial interest, there is an economic interest, and that is how they work. The shareholders, they like to see profit. So that is driving the industry, but also innovation. They need to be competitive. That is a particular aspect of industry. They have to follow standards. If there is this internal market in Europe, they have to follow the standards, the norms for construction, for products, etc. And then the third group, that was the citizen. And here you can see a nice feedback, because they choose the government. They have to pay for the products that industry are making. But they have to live and work in the buildings. Yeah? So if you see this kind of relationship, then you think that it will work. But the citizen is lacking often awareness of what is going on in the decision making at the government, where I'm working and living in these kind of buildings. The banks, they play a very important role, because whatever you want, if you want to renovate a building, or you want to create a whole new building, you have to go to the bank. And the banks, they are often very careful in just financing whatever you want to do. So, this is a nice report. This indicates a little bit where the interest should go, in particular for renovation. So this report is from a couple of years ago, but it's indicating here on the left side what is the most interesting energy saving, energy efficiency measure that you can have in the buildings. And there you can see that everything that has to do with insulating your building for renovation, lighting systems, air conditioning, more efficient water heating, etc., etc. That's all on the left bottom side. This is the most interesting part to have economically seen improving the building environment. In general, I come back to philosophy, but in general this is a philosophy that all the people are still using: energy saving, energy efficiency, improving. And probably these point 1 and 2 is what one of the 3 pillars of the Commission is. The first one was energy efficiency first. And my idea is that they forgot to mention separately energy savings. They have grouped everything together in energy efficiency. There is a basic difference between it. But, okay. So renewable energy, and this is quite a basic philosophy that should be applied. You can see that back in this, a number of European projects, we have asked people from this project to present their conclusions, and they also came up with the Trias Energetica, that for renovation just followed these steps and you get the most interesting results for renovation. They concluded also from studying several national reports that about 50% of the buildings have to be renovated. They found out also that a lot of people, they are not aware of anything that has to do with it. So they concluded also that awareness, citizens should be aware of what is going on. They should be involved in the decision making, and they should try to facilitate more easy financing for renovation. Cityfied is about to conclude this year, but you can find the details of their conclusions in the report. I put it there on the bottom. Henrik was also in this symposium. I will not say that much about it because I don't know if there is today another presentation on flexibility. Okay, so I leave everything then probably to you. Flexibility. So in the directive there is some hint that they allow, they consider also flexibility, smartness as a kind of a way to go forward. Traditionally, a building needs energy. Also in my head is still that a building cannot produce energy. Building systems, they can produce energy. But if you put your TV on the roof or in the garden, it does not change the building itself. So it's a way of thinking. But a building needs an energy infrastructure because it is consuming. But all the modern technologies, all the ways that are coming up now with positive energy houses, districts, etc., it shows that probably the energy providers needs buildings to balance. And this balancing, you can ask yourself, is it to optimize energy, emissions, or is it an economic balancing? And for who is it an economic or energy balancing? Is it for the energy providers? Because at the end, they are having an economic interest. They are a commercial attitude. One of the things that also should be discussed is the energy balance. Where does it take place? At the moment, it is the TSO and DSO, they are looking to this balancing. How to get it from production into the grid and how to distribute it. And they are balancing in different ways, using the energy market. But for building owners, it's a completely different energy balance. That's the balance that has to be taking place at this node. We consider the building as a node on the infrastructure. For the building owner or the manager of the building, it is that the energy flow can be in two directions. And it needs for the manager also quite a good communication with the providers and intelligent systems to help control and decision making. Let's return a little bit to the reference buildings, because the reference buildings are taking a more and more prominent place in how the energy performance assessment is going to happen if we want to avoid too high costs for this assessment. So what we can do with a reference building is to have detailed measurements for these dwellings and then to make it possible to compare other dwellings with these reference buildings. But of course, then you need also a reference climate. In what climate do you place these reference buildings? So there's a lot going on there. One of the things that is happening is the use of the city GML, and they have started to look to buildings in a different way. They have level of detail, 0, 1, up to 4. 0 is just the ground floor, 0, 1 is the volume, it's like a cube, and 0, 2 you can see that there is already a roof, 0, LOD 3, it's where windows are already coming in, and LOD 4, it is really taking into account also the zoning of the building. So what they are doing is the assessment of the energy consumption, energy use, or energy production in a building, using this kind of techniques and definitions of what a building can be. And what this is facilitating is knowledge from complete different sources, from satellite, from airplanes, photos, so they can make models of whole areas, urban areas, cities, whole landscapes. And then you get something like this. You can have that kind of information connected to the other databases that are coming from the cadastre, for example. Or you can have also inquiries from the municipalities, or even from the people themselves. And you can get then a kind of an energy label, which is giving information in colors. And there are people, policy makers, decision makers, they do not like numbers, they like colors, because it's much easier for them to make a decision. Maybe I'm not so friendly if there are policy makers here in the room, but it's true that they prefer colored pictures. Yeah? And then you can see the whole area. It should be reconsidered for renovation, or you should stimulate in that area that people or the house owners are doing something to improve the energy performance of the buildings. So this is the Energy Label Initiative in the Netherlands. Very important is that the definition of energy performance, and that is what I try to explain here, the difference between energy performance, energy efficiency, and energy consumption. So you see here 3 blocks. You see the blue block is the energy performance, that is the part of the fabric, of the structure in a certain climate. The green one is the energy that is required by the systems to give the minimum requirements of the building. So if you minimum temperatures, ventilation rate, etc. The systems and the energy mixed it. And that is what we call the energy performance. But if you look to the energy consumption, it is something that is going through the meters and that is also used by the end user in the building for its systems, for its refrigerators, for its television, all this kind of energy that is not a part of the building. So in short, you can see there is energy needs and there is energy for the user. Most of the time, the information on the energy performance is coming from calculation. The other part, where the consumption is, it's coming from meters. So in order to understand this relation, there is a lot of research needed, and we do outdoor testing. Our network is involved in outdoor testing, and we have also partners, they do indoor testing. Here on the bottom you see the new project in Salford. That's the Energy House number 2. They have already a laboratory, the Energy House number 1. This one is under construction, and in that climate room, it's a huge climate room, they can have 4 single-family houses. They allow also that people are living in these kind of laboratories to get an idea about the energy consumption of the families. It's a very nice concept. It is really prepared for the future because it's also studying the interaction between, for example, electric cars, heat pumps, and how does it have its impact on the network, the energy network. On the top, we can test really particular systems like advanced and dynamic facades, for example, or even roof systems. That's outdoor testing. All these kind of tests, real testing, is needed to validate calculation models, validation models. So we call it in-situ measurements. And if you look to the standards now, most of the... Okay. I only have 3, I think. Or 5. No, I don't do it. Why are we doing it? The quality check of new build, which is less than 1%. Justify renovation, which is about 50%, in particular before and after measurement for having the reference buildings. And to identify energy efficiency measures, which are the most suitable. This is a practice. Most of the time, calculation design values are hardly met in practice, and you get real figures from buildings that are outside. They are overestimating the buildings for real consumption. So there are, in short, there are 2 ways of measuring buildings. It's by co-heating, so you can go to a building, to a reference building, and you go and measure. And for that, there is now a standard under development. That's recently defined. It will be devoted, and that is probably by next year available. But there is another way to obtain this kind of information about the performance of the building. It's metering data. And metering data can be anything from electricity, gas, water, or heat. And that is having the advantage that it's accumulating all kind of data. So the more data is coming available, the much better the assessment can be. So you can see, this is a little bit the concept, but as I said before, the data, metering data, is having all the energy that is needed. And for the performance assessment of the building, it is required that you split between the building energy needs and the user energy. So there are different ways to do it. You have, for metering data, you have a lot of options. They are wireless, like the roofing sensor. You have small devices. And the advantage of this kind of modern technology is that the data is not going out of the building anymore. And you do not have this privacy problem. So that is really, people here at DTU, some of the students from DTU, they are working on this kind of analysis methods. The advantage also of these kind of new systems is that you can connect them to other sources. Yeah? You can connect them to all kind of information that you would like to have, in particular to have some forecasting of the energy flows, but also the communication with the provider on the energy pricing. This is more or less an overview, and that is the picture on the right bottom is what we would like to give to our policymakers. So this is my 4 last slide. I was talking about philosophy, the trias energetica, that was before. There is a person, Thomas Rau. He is really an architect with a vision. And he said already, everything that I do is guided by the future. If I have to design a building, if I design a system, energy system. So he started already years ago to say we should finish buying lamps. We should buy light. We should finish buying fuel for heating or cooling. No, we like to buy this kind of comfort. Yeah, we like to have the conditions that we should live in. And that's a philosophy that is changing the whole aspect. And concerning light, he made a nice contract with Philips, and Philips is now selling this as a service. Yeah? Light, not yet for residential building, but for huge office buildings. So Philips is saying, you have the light. But you can also say, another philosophy is, let the energy move with people. If they leave the home, there is a whole system that switches off or brings to a minimum all kind of conditions in the building, and it's bringing that kind of energy that was needed, it's bringing with the people to his workplace or whatever he's going to do. You can see that there are also mobility is coming in place. Well, the conclusions of this symposium, I've listed them here. Read them quietly so I can finalize. One of the things that I would like to take out of it is this, let me see where it is. Energy solutions should be for all citizens, which means that there should be also a way of avoiding this energy poverty problem. That is one of the things, like food. Yeah? All the people, they have the right to have food, but all the people, they have also the right to have a minimum comfort. So that was one of the conclusions, and the other one was that this flexibility and energy efficiency, you can discuss it at the level of a building, but probably it is more optimal when you discuss that at a more an urban level. That's it from my part. There is no time for questions. I'm sorry, I'm talking too much.